Hello everyone, so now we are going to do the multi-area lab, OSPF multi-area. If you can see here in this one what we have area 0 here, this is a area 0, and here we have the area 1 and here we have the area 2. When we start the OSPF, that time we are saying OSPF is having the area concept and area 0 is a backbone area. If you remember, we told area 0 is a backbone area. If anyone want to connect, if any area, example area 1 want to connect to area 2, we should have the area 0 in between. Like we have area 0 here, so this area 1 should connect to area 0 and area 2 also should connect to area 0. Then only area 1 root will exchange to area 2 and area 2 root will exchange to area 1. This is a procedure, this is a one condition, this need to satisfy. But in the some scenario, we don't have the area 0 in between two area. So in that scenario, we can create the virtual area. Actually, we don't have in our syllabus, in the CCNP core, we don't have that one. We have that one in the NRC. So in NRC we are going to look how we can create the virtual area also. Okay, so in the CCNP NRC we are going to discuss there. But now let's do the multi-area lab. In this one what we are doing, we taken two router. Imagine you have maybe 50 router in this area. We have 50 router in this area. But for the lab or simplicity we are taking only one router. So we have one router here, we have one more router here, we have one more router here, and we have one more router here. And this area we are saying this is a area 0, area 2, and this one is a area 0, and this is a area 1. So area 1 is connecting to area 0, because how we can say this router belongs to area 0? Because if you see here, this is one router, his one interface is in the area 0. Another interface is in the area 1. So this router belongs to area 0 as well as area 1. So this guy, we can say this is area 0 and this is having only area 1. If you see, this router is having one interface here and another interface here. Both are in the area 1. If you see, this is area 1, this is area 1. So if area 1 want to share his route to the area 2, then they need to connect to area 0. So this guy is connected to here, this will be area 1, but this interface is area 0, and this is a area 2, this one from here to here. So this guy is connecting to this router, and this router 1 interface is in the area 0. So then they can communicate. In simple words, what we are saying, if area 1 want to communicate to area 2, they need to connect to area 0. So they are connecting here this way and this way. Okay, so we will do the lab, so you will have more clear idea. But in some scenario, example, we have area 0 here, and we have area 1 here, and then we have area 2 here. Like this scenario also we can have in some condition, some situation. So in that situation we will create the virtual area. Okay, we will create the virtual area like this. We will write some extra command here, so this will become as a virtual area, this area 0, and this can connect virtually. But that we don't have in our syllabus now in this core. We will do that when in the NRC. So this lab we can do in the, what we can say, in the packet tracer, in the GNS3 or EVNG, anywhere we can do. Okay, this lab will support in all the tools, so we can do anywhere. Let me do this in the packet tracer. Okay, if you want we can do in GNS also, GNS, EVNG, anywhere we can do this one. But let's do here in the packet tracer, because this is simple only. So I will take some router. Let me take one router will be here, one router will be here, one router will be here, one router will be here. As we are taking 4 router, let me make this little up, and then I will increase the size so we can see this little big. So I will give the name also. Example, I will give this is a R1, and this is a R2, and this is a R3, and this is a R4. Let me keep like this. So now we will create some area. So first of all, let me connect the routers. So this interface is connecting to this interface, and this interface is connecting to this interface. This interface is connecting to this interface. Okay, so this is having the 4 router. We will create the multiple area here. We will create the multiple area here in this scenario. And we can create the loopback. We can take switch and connect also, but instead of doing that one, we can create the loopback. So what I will do, I will create one loopback here this way, and I will create one more loopback like this way. So we will see what IP schema we can give. I will use here, let me take some colors also so we can differentiate. So let me take some color, maybe let me take this green color. I will make this color here, so we can say this is the area 0, and I will change the color, this one something different, and I will say this is a area 1. So I will give this one here. Okay, like this way. I can move this little here. This is area 1 we can say, and I can put the same color here. Same color here, because these are also in the area 1. Now I will change the different color for area 2, so I will say this is area 2, or I can take this whole thing. So this one we can say this is area 2. Let me move this here. This all are the area 2. Look little different here. Okay, so this one is the area 1, this color, sky color, and this yellow is the area 2, and this green is the area 0. So now we can give the IP schema. We can use, let me write here, this is a area 0, and this will be area 1. Here also area 1, and this is a area 2. So we have 3 area here. So what I will do here now, I can give the IP schema. Whatever IP schema we are planning to take, we will write here. So generally, as we are doing same thing, I will write here 192.168.12.0/24, because here is R1 and here is R2, so I will take as a 12. And here in this side, what we can give in this side, this is a R1 and this is R3, so we can give here 192.168.13.13. Why I am taking 13? Because this router is 1, this router is 3, that's why I am taking 1 from here, 3 from here. You can take anything whatever you want, but I am using this one. Okay, and here I can take the IP schema 192.168. What I can say, this router is 2 and 4, so I will write 24.0/24. Okay, and here we can use, this will be this interface in between them, and this will be in between them, and here we need to have something. We will create the loopback 0, so I will give here loopback 0, and what we will give here, I will give the IP as a 3.3.3.3, because we are using the, what we are using here, we are using the, what we can say, area router 3. This is a router 3, that's why I am giving the 3.3.3. You can give any IP, and I will give the /32. We can use /32, whatever we want we can use. So I will give /32 here. If you want, we can give /8 also, no problem, we can give anything. So here also I will create, but this is a router 4, so I will give here 4.4.4. so this is 4.4.4. just this is IP schema, whatever you want you can give. Just I wrote whatever I think I give here, but your wish, whatever you want you can give, no problem. So this is the IP schema. Now we need to start configuration. Now we need to start the configuration. So how we will do the configuration? Let me take the notepad, as always we are using, and it will be easy because we can copy paste the same configuration very easily. So now I will write here, first of all, the name of the lab. Name is OSPF multi area, OSPF multi area lab. And here we can give the R1 configuration here. Same thing as we do before, enable config t host name R1, and then what we can say interface fast Ethernet 0x0, and then we can assign the IP address 192.168.12.1 255.255.255.0, and then we write no shut here. This is the IP for this interface. Now we need to assign this interface, so I will copy the same thing and I will paste here. This is a 0x1, so I will write here 0x1, and here the IP address will be 13.1. This will be 13.1, this will be 13.3. If you have confusion, I will write here. Here for this router all the IP will be .1. For this router all the IP will be .2. For this one all the IP will be .4, and this one all the IP whatever we are using .3, .4. This one is .4, and here this will be .3. Okay, so now what we will say, this configuration here, this is the 192.168.12.1, this is a 192.168.13.1 for this both interface. So this is the R1 configuration. I will copy this one, I can paste here, I can divide this page and I can paste for the R2. Okay, and if we want to configure the OSPF, we can do the OSPF configuration also. How we will do the OSPF configuration? Let me show you here. We will write router OSPF1. Okay, router OSPF1, then we can write the interface method, or we can use whatever method we want, we can use. Example, if you want to use network, we can use network command, or if you want to do interface method, we can do interface method. So I will write interface fast Ethernet 0x0. So this interface we are enabling the OSPF. So we go inside this interface. After that we can write here what we will write. We will write like IP OSPF1 area 0. This is area 0. Okay, how I am saying area 0? I am doing the configuration for this interface. So this interface is in area 0. Okay, this two interface, this one and this one will be in the area 0. So that's why I am writing this area 0. Okay, so now what I will do, I will copy this whole thing, because we have two interface, we need to enable in the two interface. So I will paste this here, and if you see, this is an interface fast Ethernet 0x1. So I will change this as a 0x1 here, and this is the area 1. If you see this interface is in area 1. So this will, I will change this to 1. Okay, so now it is changed as a area 1. So this is a configuration for R1. Now we will go here, I will change this to R2, this one also I will change to R2. I am here, this is a fast Ethernet 0x0 12.2. So this one I will change as a 12.2. So this one is okay, and if you see this one fast Ethernet 0x1, this should be 24.2. So I will change this as a 24.2. This is the 24.2 here, and this is a .4. So this one we are writing, so I wrote 24.4, and then we need to configure the OSPF. So I will copy the same thing what we done here, and I will paste here, we will modify here. This is the interface fast Ethernet 0x0, this one is in area 0, so this is okay, no issue. And this interface fast Ethernet 0x1, so we go inside that interface and we write IP OSPF1. Why this one? Because whatever process ID we write here, that should come here and here also. Then area, what is the area? This one, this is the area 2. So here I will write area 2. So this way we configure the OSPF in router 2. If you want to do network method, you can do with network method also, no problem. Here what I am doing, I am using the what we can say, I am using the interface method. But if you want to use the network method also, you can use, no problem. So this one is finished for R1 and R2. Now we can go for R3. So let me copy this whole configuration from here to here, and I will paste here, I will make changes. So this should be 3, this will be 3, and if you see, this is a 3 fast Ethernet 0x0, this interface, and what will be the IP 192.168.13.3. So I will write here this one as a 13.3. 192.168, let me, yeah, 192.168 13.3. Okay, for this interface I am saying. What is the other interface for this router? This is a R3. We have loopback 0. So we can write interface loopback 0. Okay, and what will be the IP? We are writing 3.3.3. So I will change this here as a 3.3.3.3. And then what I will write here? 255.255.255.255. We are writing 32. 32 means, if you see here, we are writing this /32. 32 means all 4 time is 255. That means 32. 255.255.255. If you want, you can take /8 and you can write only one time 255, remaining will be 0. But as we taken 32, so all should be 255. If we have /24 means 1, 2, 3 time will be 255, this will be 0. But now we taken 32, so all should be 255. So this one, what we done, we assigned the loopback 0, we assign this IP. Okay, this is finished for loopback 0. No need to write no shut, but we can keep no issue, because loopback always up. We will not put no shut, automatically it will go up. So this is finished. Now what we can see, this one F0 by 0 is in area 1. So this is a router OSPF 1 fast Ethernet 0 by 0. This is a 0 by 0. And what we can say, IP OSPF, what is the area for this interface? 1. So we will write here as a 1. And then interface, this will be changed to loopback 0. Okay, and this one, what we have, IP OSPF 1 area, this is also 1. So I will write here also 1. Okay, let me repeat what I done here. This is a router 3. This one is a router 3. We assign IP to fast Ethernet 0 by 0. This is a fast Ethernet 0 by 0. This is a IP dot router number. So this dot 3. So this is a 192.168.13.3. This is the /24. /24 means 3 time 255. And then after that we have loopback 0. So this is a loopback 0 and this is IP. We have 3.3.3.3 and /32. /32 means all 4 time we have 255. And after that we are doing the OSPF. How we will do? We will write router OSPF process ID. We are using 1. You can use 2, 3, whatever you want. We are using 1. And if we use 1 here, here also be 1, here also be 1. If you use 2 here, this should be 2, this should be 2. So this is okay. And then which interface we want to enable the OSPF? This one and this one. So we need to go inside this interface. How we go? We write here interface fast Ethernet 0 by 0. Then we write IP OSPF 1 and area. This is a area 1. If you see, this is a area 1. And here interface loopback 0 and same command and area. This is also area 1. So we wrote area 1. This is the configuration for R3. Now we need to do the R4. So I will copy the same configuration from here to here, and then we will paste this configuration in R4 also. So now if you see, this is a 4 R4 and here also 4. And what else we have? This one is a 24.4. So this is a fast Ethernet 0 by 0 24.4. So I will write here 24.4 this one. And other interface is loopback 0 and you have here 4.4. So let me change as a 4.4.4.4 and remaining will be 255 because here also we used /32. Okay, and if we go here, this is a router OSPF 1 and this interface we are enabling the OSPF, and this one is having the area 2. So I will make this as a 2, and loopback also having the area 2. So I will change this as a 2. So this way we will write the configuration. Now we can copy paste and we can verify. So I will copy this one and I will go, this is the R1. So I will go inside the R1 and I will paste this here. Okay. So we will paste the configuration here. If you see any error, anything come here, nothing. All are okay. This all are okay. No error. So now we can copy for the R2 and we can paste. So I will take this for R2 and we will go in the R2 also here and we can paste here. I will paste, everything is okay here, or any error we can verify here. No error, nothing, everything is good. So now R2 also finished. So we will do for R3. This one we will take from here to here, and now I will go in the R3. I will put here no, and then I will paste the configuration here. So I think everything is good. We can press enter. Then last one is a R4. So I will go here in the R4 and I will copy this configuration. We will go inside R4 here, and then we can press this one enter, and I can copy paste this configuration. If I see here no error, nothing, everything is good, so we can verify. It will take some time. After that we will have the neighborship. So we need to check we are getting this 4.4.4 root here or not, and from here also we can check 3.3.3 roots are coming or not. We can verify that one. So now if you see we have neighborship here, so now we can verify. We can check also. We can write here show IP root OSPF. If you see we have one root here. We need to wait, maybe it will take some time. What root we learn here? We will see 12 dot. We learn this root, this one. Okay, from if we are checking where in the R3. In R3 we are checking, we get that 192.168.12.0, this one. If any traffic want to go here, we need to send to 13.1. And if you see here we are getting O means OSPF as we discussed before. But now if you see here what we are getting here, let me write in the normal way, show IP root. If you see here, now we have the more two roots also. Okay, but example, if you see this one OIA, this one also OIA, this one also OIA. Here if you see we have IA. O means OSPF. IA means inter area. Inter area means, we need to remember, inter area means outside area. Example, I am here in the area 1. I have another area as a area 0. I have another area as a area 2. These are connected like this. If I am getting any root and it is written as OIA, means we can understand I am learning this root from the OSPF, but this is not in my area. If we have inside area, then we have intra area. Intra area means inside our area, but now we have inter area. If we get IA, that means inter area. Inter means not our area, outside area, other than our area. We are area 1. If we are getting root from area 0 or area 2, it will represent in this form OIA. If you see we are getting the root 4.4.4/32 from where? From here 13.1. We need to send the traffic, but this is coming from OIA, means O means OSPF. If you have only O means we can say intra area. Intra means same area. Inter means different area. Just remember like this. Inter means different area. Inter means different. Intra means same area. So if we are getting the root from the same area, then we have only O. But if we have IA, that means inter area. Inter area means different area. So what we can say here, I am getting this root from different area. I can verify like this way also. I am getting the root, this 3 root I am getting from different area. This one 4.4.4 and 192.168.12.0, 192.168.24.0. These 3 roots I am getting from different area, not from the same area. How I am saying this one? Because I am here in the area 1. So I am not getting this root from the area 1. If you see 4.4.4 is coming from the area 2. That's why I am saying this is from the different area. And if you see this 12.0, this one 12 means in the area 0. And if you see 24 means area 2. That's why we are having here IA, inter area. Inter means different area. Now we can check some more property also. We can check here. We can check here in the router R2 or R1 we can check, because if you see here, this is a router, this one or this one, this is connecting different area to area 0, and this router also connecting different area to area 0. If you remember before what we told, if any router which is connecting the different area to area 0, is known as ABR, area border router. Area border router. So we will verify that one. In theory, what we told that if any router is connecting to the area 0 from the different area, like different area connecting to area 0, that router is known as area border router, as per our theory what we discussed. So now we are going to verify. Here also this is area 0. His one leg is in the area 0, another leg is in the area 1. So now this router is connecting area 1 to area 0. So this guy should be ABR. ABR means area border router. So we are going to verify that one. How we can verify? We can go inside that router and we can type here. Let me show you here. We can go here and we can write here show IP OSPF. If you see, we write show IP OSPF, and if you see, this is a area border router. We are getting here, this is a area border router. So with this one, what we can say, this is the area border router. Area border router is the router which is going to connect the different area to area 0. That's why we are getting area border router here. And if you go here also and type that one, you will get here also, because this router also connecting the different area to area 0. IP show IP OSPF. If you see here, it is a area border router. So what we are saying, a router R1 and R2 are the area border router which is connecting the different area to area 0. This is simple lab only. Let me show you what we have here. This is a simple lab multi-area. Here area 0, here area 1, here area 2. How we can configure? Here we configure by using the network command. But just now in our real lab, just now what we done, we use the interface method here. Interface method. Configuration is simple, just you need to follow and you need to do. So this is a configuration, and we check here show IP OSPF, and we are saying this is a area border router. And we check, we get the root. If you want to make sure, you can ping from here to 4.4.4. If I ping here, I ping 4.4.4, you will have the reply. Okay, it is working perfectly. So what we are saying here, just we need to remember how we are doing the configuration. As per our condition in our previous class, we told when we connect the any router, the opposite end, this one, this way, this should be in the same area. This interface should be in the same area. So same we have area 0. So we put this and this in the area 0. And if you see, this directly connected interface should be in the same area. This we put in area 1, this we put in area 1. This one also by default we have area 1. And if you see, directly connected interface should be in the same area, same subnet mask, same hello timer, same dead timer as we discussed previously. So we did not change hello timer, dead timer, anything. And we are using the same subnet here, and we are using the same area here, also area 2, here also area 2. So they will exchange the route and they will become a neighbor. And one more thing what we learn that if any router which is connecting the two different area, that router is ABR, and just now we check that one. How we will check? We will write show IP OSPF. With this command we can check that router, it is ABR or not. So these both guys are ABR. So this is a simple lab for the multi-area. Okay, this is the lab for multi-area. I can write here OSPF multi-area lab. Okay, let me save the configuration for these routers so I can upload in the drive. You can download there. So let me save this configuration. Here also I will save. Very simple only, this is very simple. Okay, before we did not done, now we done the multi-area. So how we will do? Simple, just we need to configure